we OSI we have different layers. So each layer we have different applications, or so it helps in troubleshooting.
Okay.
You know about the issues and.
Okay. Fine. I'll come back to you with some more questions. Now, Santosh, what do you know about OSI?
Yes, sir.
Okay.
So I know it has 7 layers, and it is basically shows the level of network from the end user to the
Okay. Fine.
final
I
stage.
also want to ask you more questions, but later. Now I'll come to Kumar. You said it helps to troubleshoot. How?
Yeah, we have 7 layers. So depending upon the issue which we are facing, we
Where
will
you do
go
you
to that
see
particular
do you see
layer,
layers
and then
anywhere?
it helps in troubleshooting. Example, no, depending upon the situation, I mean the issue, we can correlate to which
Okay.
layer the issue is.
Fine. Open system interconnect. You see
And
the word open.
troubleshoot accordingly.
System means any device that is in the network which can interact, which can interconnect and interact. Open to interact. The systems that are open to interact. The systems that can communicate without any problem. That is the real meaning of OSI. Open System Interconnect is a standard prescribed by ISO. The certifying company, ISO, they only prescribe this OSI, Open System Interconnect. So they prescribed a standard. ISO prescribed a standard. When you follow that standard while manufacturing a laptop or a computer or a cell phone or an iPad, then there won't be any problem in interacting with other existing network device. When a manufacturer have got his own idea in developing his computer, then that computer cannot interact with other vendors. See, today we all have different brand iPads and laptops. Sorry, when I say iPad, it is Apple. So we have different type of laptops, different vendors, different size, different profile. Some of you may have Toshiba laptops, some of you may have Sony laptops, some of you may have Dell laptops, some of you may have HP. Even though the vendors are different, even though the operating system also not same, some have Windows 10, some have Windows 7, some have Linux, some have Ubuntu, some have Mac. Even though the operating system is different, even though the hardware configuration is not the same, some of you have got 32 GB RAM Xeon processor, some of you have just 8 GB RAM Intel, some may have AMD processor with 4 GB RAM. Some of you have a Windows cell phone, mobile to join the class. Some of you have got laptop, some of you have got desktop. They all communicate now. Someone in US assembles most of the products he ordered in China. He imported in US, assembled it, and put a brand named Dell and he sells to us. There's another guy, Shivan Nadar in Tamil Nadu. He also assembles computer, buying the product from same China market, and he calls his computers as Wipro computers. Wipro. But these two interacts. No problem. The reason is both the vendors have followed the same standard, which is OSI. Not only the end device like laptop, even the routers, the switch manufacturers, router manufacturers, firewall manufacturers, they have all referred one common book called OSI. So OSI is a reference model. OSI is a standard. So when you follow this standard, when you refer this book and develop any device as per this book, as per this standard, that device is now, that system is now open to interact. That system is now open to connect. No problem in connecting. They are ready to connect. OSI is a reference model. It's a standard using which all the network device, it can be router, it can be firewall, it can be a computer, it can even be a mobile phone. They all built following this one book called OSI. And this has got 7 layers, as you said. And these 7 layers explains us what all involved in preparing a packet, in building up a packet, in building the data so that the data can be sent over cables, which only understands the electric signal 0 and 1. We call this binary system number. You see, whether you are doing a money transaction or playing an online game, in the wire, it is not going as a game or money. It goes as zeros and ones. Important traffic, less important traffic, everything goes in zeros and ones. If you send email, in the wire it is 0 and 1. If you send a PDF, again it is zeros and ones. But when you send PDF, my computer can understand that it is a PDF. When you when you do telnet, my computer understands that you are expecting telnet from me, telnet session from me. How is that possible? It is because the standard explains how it need to be presented to that wire so that wire will carry even the meaning of the data that you send. It not just carries your data, it also carries that it is a PDF and it is for this particular destination. And when the destination is arrived, the destination device should open like this. And when he opens, he has to open with the Adobe Reader because it's a PDF. So the OSI working on sending side and receiving side, they understand each other because they are of one standard. So when you say PDF, my laptop understands PDF. How? Because the marking that you do to mention that this is a PDF is the same marking I also follow in my laptop, in my OSI standard. Right? So if you show red color and ask to relate this color to humans' day-to-day life, mostly they will say "Varumai niram sivapu," because they were taught that red means poverty. So everyone unanimously say, when I show red color, they say poverty. Because in Tamil Nadu, that slogan is very famous. Varumai niram sivapu. Likewise, when a sender marks PDF in the presentation layer, that is why it is called as presentation layer. Your computer is presenting to the network that, hey, this is a PDF. Tell the receiving guy that this is a PDF. So when the receiving guy receives the data, the receiver's presentation layer says, this is a PDF. You need to open with Adobe Reader. Don't try to open with a browser, or even a browser can support PDF, but don't try to use something else. This is a PDF. So only the right application to open PDF is going to be used by the application layer on the receiving side, because the sending side presentation layer has marked as PDF, has encrypted. Here the word encryption doesn't mean that it's been ciphertext. No. Here it means that the presentation layer is mentioning to the network that this need to be handled as PDF. So in short, what I want to say is Open System Interconnect, that 7-layer, explains the steps need to be carried to make our data to be eligible to be transported over the network, so that any network device will understand what that packet is, what that data is, and how to deal with the data. When a receiver receives that packet, he receives that data with the same meaning that you have sent. So no other meaning given to the message that you send. If you say hi, hello, then the receiver also receives hi, hello. There is nothing newly added by the receiver's computer. The same meaning that you conveyed is being learned there. It is because of this OSI 7 layer. So 7 layer describes the 7 different functions, 7 different add-ons that is attached to your data, so that your data will be conveyed the same way as you send to the destination. Because your network is not a human being to take your message. Network is not a human being. Network is a wire which understands zeros and ones. So you need to make that network understand what you want. Or you need to utilize that zeros and ones and send the data in such a way that when that same zeros and ones received on the receiving side, the data that you send will be received, not simple some other data or zeros and ones. If you'll send a Word document, it should be received as a Word document there. For that, there is a preparation needed for a packet to go from one computer or for a document to go from A to B, not only the address of A and B needed, much more is needed. Because this is not a human being that is carrying your English language letter or a document that you send. It's a wire which knows only zeros and ones. So this OSI explains that add-ons that is done to your document so that the document will be carried on the other side, carried to the other side, the same way as it is sent. நம் தகவலை அதே அர்த்தத்தோடு கடத்துவதற்கு தேவையான ஏற்பாடு, the preparation, is what that 7 layers. அதில் ஒன்றுதான் IP address, அதில் மற்றொன்றுதான் MAC address, அதில் மற்றொன்றுதான் port number. இது மூன்று மட்டும் போதாது. So other than this IP address, MAC address, and port number, we need session, time to be maintained. We'll talk about that in detail in a few minutes. We need a presenter to say that this is a document, not something else. And we need application to understand what the presenter says and open the document with that application. So there are 7 levels of preparation need to be carried to your data to send your data and to receive that same data on the other side. Because A and B followed the same standard, whatever A send, we can understand very well. Though B is from Bhopal, there's a computer manufacturer assembled it in Bhopal, and A is in Andipatti. Someone assembled in Andipatti, but still they both can understand, Andipatti and Bhopal, because they both have followed OSI, Open System Interconnect. The motherboard size may be different. The chipsets may not be the same, but still they do understand each other, because the logic in preparing the packet, the flow in preparing the packet is same. OSI standard. See, wherever you go, KFC or anything Domino's, it is same. At least within a country, Domino's, pizza, there is something called Dominator. McDonald's, Dominator. Go to any McDonald's and eat Dominator, it's same taste. It is because there is a standard in preparing the Dominator. Put this one first. Put that one next. Don't change the order. Leave it for 3 seconds. Put the other ingredients. Leave it for 7 seconds. So they strictly follow that. And it comes with the same taste. Same way. A and B can have the same output because they both have followed the same standard. Now, let's go to the other side of OSI. So far what I said is it's a standard that need to be followed in order to interact, understand each other. And also I said OSI is 7 functions that is carried on to your data to be acceptable and to get delivered in the same manner that is sent. 7 தயாரிப்பின் படிகள் தான் OSI என்று கூறினேன். Then how this is used to troubleshoot? How OSI layer helps us to troubleshoot. You see, this OSI layer has got 7 layers, as you said. If any one of this layer forget to add what's supposed to be added to the data, then the packet will not even go out of your device. All that 7 layer ingredients need to be added to get the taste. All the 7 layer properties need to be added to your data in order to send the packet out of the device. ஒரு லேயர்னுடைய சேர்க்க வேண்டிய விஷயம் சேர்க்காம போனாலும் அந்த பாக்கெட் உங்களுடைய கம்ப்யூட்டரை விட்டு போய் வெளியே போகாது. உதாரணத்துக்கு, for example, if MAC address is not added, then the packet cannot leave. We call it as encapsulation failed. All 7 layer, when it got added to the data, we say encapsulation pass. We say it's a eligible packet. So now, how do you use OSI layer to troubleshoot? We have something called Wireshark. Let me open that. So this is a tool called Wireshark. You can see here, Wireshark 4.2.2. Now, I got a lot of interfaces in my laptop in which only these two, I can see some signal, some data getting in and going out. Now, even this loopback traffic is not really going. It's straight line. Means there is no data read and given. Only on the Ethernet cable, I'm seeing some data coming in and going out. You see Wi-Fi? Actually, I have off my Wi-Fi. You see here, I have not connected to my Wi-Fi. That's why it is a straight line. Now I'm going to connect to my Wi-Fi, and you will see some data. Look at this. Some data started using the Wi-Fi. Some data started using my Wi-Fi. So right now, as I'm talking to you, my voice is going out of my laptop via Wi-Fi as well as the wired port. Both the port. Load balancing happens. I'm going to disconnect the Wi-Fi again. I disconnected. That's all. Now the packets are going only through this Ethernet wire. Only through Ethernet wire. You see, again, it has become a straight line. The Wi-Fi has become straight. Now, I'm going to sniff this Ethernet wire. Look at this. Lot of UDP packets. Voice will use UDP. Now, look at this one here. Let me zoom it for you. You see the middle portion. Okay, let me do. Okay, you see this portion. This is the Ethernet section, which is layer 2. And I can see my laptop MAC address. This is my Huawei router's MAC address, my gateway MAC address. Showing MAC address is very dangerous to public. But I have trusted my audience and I have shown. Please don't attack. Now, you see layer 3? network layer. You got source and destination IP addresses. Source IP address, this is my laptop's IP address. And I am talking to you using Google. This is Google's address. 142.250.82.17. And it is UDP because it's a voice traffic, voice and video traffic. And you see 131 bytes of information. See how it is going in hexadecimal format. This is my voice. You see how it is going. And this is not layer 1. In layer 1, it will go in zeros and ones. In the wire, it will go as zeros and ones. Okay, this is layer 3 actually. And UDP is layer 4. And Ethernet is layer 2. This frame is also layer 2. These two are, the first two are layer 2. So now I want to tell you how OSI layer helps you to troubleshoot. Because you know that Internet Protocol layer is layer 3, you can now see that whether the packet is coming from the correct source that you are expecting, whether it is going to the correct destination that you want it to go. In this way, you can use OSI layer to troubleshoot. OSI layer வச்சு நம்ம ஒன்றும் ட்ரபுளிங்கெல்லாம் கண்டுபிடிச்சிட முடியாது. OSI லேயரில் கேப்சர் பண்ண ஒரு பேக்கெட்டை கேப்சர் பண்ணீங்கன்னா அந்த OSI லேயரின் அறிவை கொண்டு எங்கே என்ன பார்க்கணும்னு நமக்கு தெரியும். லேயர் 3 விஷயம் இங்கே அந்த கம்ப்யூட்டர்ல இருந்து தான் பேக்கெட் வருதா அப்படின்னு நான் எப்படி தெரிஞ்சுக்கிறது? இங்கே வருவேன், இங்கே வந்துட்டு சோர்ஸ் அட்ரஸ் அதுதானான்னு பார்ப்பேன். இல்லைன்னா இல்லை ப்ராப்ளம் எங்கேயோன்னு தெரிஞ்சுக்கிறேன், அவ்வளோதான். வேற ஒன்றும் இதில் பண்ண முடியாது. OSI லேயரில் வச்சு நம்ம ட்ரபிள் ஷூட் பண்ண முடியாது. இங்கே வந்து நான் பார்த்துக்கலாம், கரெக்டு தானா, இந்த அட்ரஸ் தானா, நம்ம அட்ரஸ்ல தான் வருதா, இல்லை வேற ஏதாவது அட்ரஸ்ல இருந்து வருதா, நம்ம அட்ரஸே வரலையா இங்கே, ஐயோ வரலையே, அப்போ என்ன ஆச்சு போய் பார்க்கலாம், ஏன் என்ன ஆச்சு, ஏன் வரல பார்த்துக்கலாம். ஸோ let me repeat. With the knowledge of OSI, I can use this tool to check whether what I supposed to see is there or not. That's all. OSI is not going to take your finger and point to the trouble where there is a trouble in the network. No way. Our knowledge only will take you to the place where the trouble is. Our knowledge on protocols, our knowledge on how it works, that is what going to drive you towards the trouble. OSI is not going to do any magic to drive you to the trouble. With the knowledge of OSI, you will just come to this type of tools like Wireshark and see what you're supposed to see is being shown or not. If it is not there, then you will need to go and check. That type of troubleshooting is what you can do. See, because you have OSI, you know that there is something called IP address added to the data, MAC address added to the data, port number added to the data. There's an application involved in generating the data and receiving the data. There is a presentation layer which is helping us to present it to the network. There's a session layer that sets the time frame. See, if there is no OSI, you will not know all this thing. So you will not know what the trouble might be. So let us try to understand that 7 layers one by one now. The top layer is what called as application layer. Which is layer 7. Even though I am calling this as top layer, you cannot call it as layer 1. Even though the traffics are generated in this layer, you should not call this as layer 1. தகவலின் பிறப்பிடமே அப்ளிகேஷன் லேயர் தான். ஆனாலும் அதை லேயர் 1 என்று அழைக்கலாகாது. ஏன்? ஸ்டாண்டர்ட். அப்ளிகேஷன் லேயருக்கு 7 கொடுத்துட்டாங்கன்னா அது ஸ்ட்ரிக்டா ஃபாலோ பண்ணிக்க வேண்டியதுதான். அதனாலதான் அது ஸ்டாண்டர்ட்னு சொல்றோம். அப்படி இஷ்டத்துக்கு மாத்திக்கிட்டு அது பேர் ஸ்டாண்டர்ட் ஆகாது. ஸோ அப்ளிகேஷன் லேயர் இஸ் ஆல்வேஸ் லேயர் 7 because it's standard. As per the standard, number given to application layer is 7. That may be the first layer in the conversation, but still it is layer 7. So using this layer, what do we do? When you want to send a mail, you open a mail client page. What is mail client page? Gmail.com. You log in, right, into Gmail. That is the mail's client. That's where you click the compose button and send a mail. That's the application that can send a mail using network. Likewise, we have different applications for different job. If I want to transfer some file, I need an FTP application. You might have heard about this WinSFP. WinSFP. SCP. Win, not SFP, SCP. See, file transfer protocol. WinSFP, NSF, WinSCP. So using WinSCP, you can do file transfer. That's an application for transferring files. So likewise, we have various applications for different job. Right now, I'm talking to you. Am I using WinSCP to talk to you? No, I'm using Google Chat. That's an application layer. Any application that interacts with the network, we call it as application layer in OSI. So you may have many applications. Even MS Paint, which I'm using now to scribble, is an application, but this is not an application layer in OSI. Why? This paint cannot interact with the network. So any application that interacts with the network is under this layer called application layer. When you open that WinSCP, presentation layer says, which is layer 6, says use FTP. Use FTP. That is why it is called as presentation layer. It presents to the network that this is a file transfer. Because the user has opened that WinSCP application, the protocol that needs to be used to handle the traffic is not HTTP. It's not ICMP. It should be FTP. That's the job of presentation layer. It picks the right protocol based on the application that you use. Are we saying anything like use SF, use UDP, use real-time protocol? No, we don't say any. We don't give instruction what protocol to use. We simply double-click and we open, and then we send mail. Have you ever said use POP3 post office protocol or simple mail transfer? No. Then who is telling those things? Presentation layer. That is why we call it as presentation layer. It presents. பால்காரனுக்கு டேங்க் உள்ள லாரி தான் தேவைப்படும். ஓப்பன் லாரிலாம் கொடுத்தீங்கன்னா பால் வியாபாரம் பண்ண முடியாது. அவனுக்கு டேங்க் உள்ள லாரி தான். விறகு வியாபாரிக்கு டேங்க் உள்ள லாரியை கொடுத்தீங்கன்னா அது அவனுக்கு பிரயோஜனப்படாது. ஓப்பன் லாரி தான் கொடுக்கணும். Likewise, when you open a web page, HTTP, HTML, all these are the presented protocol. When you open a WinSFP, SCP, FTP is a protocol that is presented as per the OSI standard. See, because the standard is there, the developers have followed that and developed like this. The operating system, when they design the Windows operating system or Linux, they all have the same meaning. If anyone is opening WinSFP, FTP protocol. Linux also will say use FTP. Windows will also say use FTP, because both have followed the same book. Session layer. Layer 5. You see, session is very important. You're going to meet someone very busy person. You cannot go and come at whatever the time that you want to go. There is a appointment time given to you. You need to go in that time. Only then you can see that busy person. Why is the appointment time given? So that when you go there, no one else will be there. You will be served. 10:15 வந்துருங்க அப்படின்னாங்கன்னா 10:15 போனீங்கன்னா வேற யாருக்கும் அந்த டைம் கொடுத்துருக்க மாட்டாங்க. நீங்க அப்படியே ஹாயா போய் உட்காந்து பேசி டீ எல்லாம் குடிச்சிட்டு வரலாம். But when there is no session, if there is no appointment, there is no guarantee that when you go there, tea will be served. He will be ready to talk. Sometimes the door may not be even opened for you. That's why you need an appointment. Computer is a device which can simultaneously run many sessions. But one session will not conflict the other session because the session layer maintains the time frame for each session. ஒருத்தன் கொடுக்குற டைமா இன்னொருத்தனுக்கு கொடுக்காம இருந்தா ப்ராப்ளம் இல்லை, கிளாஷ் ஆகாது. இவனையும் 10:15 வர சொல்லிட்டு அவனையும் 10:15 வர சொன்னா பிரச்சனை. Session layer will never do that. Session layer maintains session, meaning what? It provides time frame for each conversation, so that one conversation won't be hindrance for other conversation. Let me give you an example. When you are downloading, you will see like 80 MB file, and estimated time 3 minutes. That is because of the session layer. The session layer calculates, okay, there is 80 meg file to be downloaded. Per second, how much is downloading? So it calculates. If it is downloading in this speed, for the available processor and the sessions, within this time, the 80 meg will get downloaded. So session layer calculates it. After 1 minute, if you go and see, it will show you remaining 2 more minutes to finish down. After another 1 minute, if you go and see, it will say 60 seconds left. How is this possible? Because there is a session layer keeping track of how much is downloaded, how much is left, and how much time it will take. Session layer is very important. Next, transport layer. Layer 4. As the word says, transport layer. This is the layer that takes responsibility of transporting your data without getting lost. You see, if you want to send a bag of rice, you need a beam boy to carry. If you give that bag of rice to a small boy, no guarantee that bag will reach the destination because the small boy cannot carry for long distance. You need a beam boy. Likewise, when you want to send a huge amount of data, now transport layer will calculate how much is the bandwidth on the path and how big is the data need to be sent. Can this big data get accommodated in the path? No. Then what I should do? What will you do? I don't have a beam boy, but I want to carry one bag of rice. But the capacity of boy is only 2 kg. But the bag of rice is 20 kg. Then what I need? I need 10 chota boys who can carry 2 kg each. That is what transport layer does. The huge data that you want to send gets segmented into pieces so that that piece can easily travel without any problem. Because the traveling path, the medium, has got some limitation. So the sender cannot send a large size packet into a narrow path. So before sending, the transport layer checks the path's capacity and cuts your data into pieces so that the piece can go easily. But when you make it into pieces, on the receiving side, the receiver also should know which piece will come first and which piece will be second. For that, a sequence number is also added to the piece, to the segment. So that on the receiving side, even if the packet goes in a wrong order, it can be rearranged easily. See, the internet is a web. You got multiple paths. Sometimes, segment 10 will go first, and then segment 6, and then segment 1. So to rearrange, because the segments are numbered, because the transport layer not only segments the data, it also provides a sequence number. Because it also provides a sequence number. On the receiving side, it can be easily rearranged. The receiving side transport layer will rearrange it and give it back as a data, the complete data. See the job of transport layer. It takes care of transportation. Without struggle, it need to be transported. When you don't have beam boy, sending 20 kg is a troublesome transport. It's not a comfort transport. You got only small bandwidth link, chota boy. So you need to send 2 kg of rice only. Transport layer takes the responsibility of transportation. That's why it is named as transport layer. Transport layer also does few more things like assigning port numbers, deciding whether to use TCP or UDP. All those things we'll discuss in our next class. Now let's go to the next layer called network. As the word says, network, this is the layer in which the source and destination IP address gets added to your segmented data. Once the IP address is added by the network layer, your data will now be called as packets. When your data is in transport layer, it is called as segments. When the segment comes down, an IP address, source and destination IP address is given. Using the IP address, we can identify the network to which the packet belongs to. So after getting an IP address, your segment will be called as packet. So your data is called as packet here. Our data in transport layer is called a segment. Our data in network layer is called as packets. More is coming later. Next layer is data link layer. This data link layer is the place where the source and destination MAC address gets added. And the data in this layer will be called as frames. I showed you in the packet capture frame. I showed you 3 layers in the packet capture. One is layer 2, the other one is layer 3 with source and destination IP address, and the other one is UDP layer, which is transport layer. Let me show you one more time that segment ID, all the stuff. Wireshark. Pick one of the packet. You see, in the transport layer, this is UDP. This is the transport layer. You can see here timestamps, destination layer, and if you go up, you got checksum value, index value. This is UDP, right? Let me try some TCP packet. Okay, I got a TCP packet here, layer 4 TCP. See, segment length and the sequence number. Yeah, sequence number. And you see the segment size, 20 byte. That's the segment size. Let's close. So the data link layer adds the MAC address and then it sends to the physical layer, which is considered as layer 1, in which the data goes in the form of bits or bytes, electric signal. On the receiving side, the reverse process will happen. So in our next class, we will talk about the data encapsulation and decapsulation. Sending side, what we saw is encapsulation. We'll go through this OSI layer one more time, touching few other things that which I have not touched today. Right. So do you have any question on what I have covered today? OSI, Open System Interconnect. Thank you. Santosh? கொஞ்சம் விளக்கமா கேளுங்களேன். என்ன மாதிரி போற அப்படிலாம் போகுது. அப்படிலாம் போகிறதுக்கு வாய்ப்பு இல்லை. டிரான்ஸ்போர்ட் லேயர் அதுக்கு ரெஸ்பான்ஸ் எங்க போய் சேரணுன்றதை முடிவு பண்றது நெட்வொர்க் லேயரும் டேட்டா லிங்க் லேயரும் தான். அங்க போய் சேர்ந்த பின்னாடி என்ன சர்வீஸை கேட்கணுன்றதுக்கு உத்தரவாதம் கொடுக்கறது தான் டிரான்ஸ்போர்ட் லேயர். டிரான்ஸ்போர்ட் லேயர் வந்து எப்படி போய் சேர்க்கறதுன்னு தான் பார்க்கணுமே ஒழிய எங்க போய் சேர்க்கணுன்றத டிரான்ஸ்போர்ட் லேயர் முடிவு பண்ணாது. இது எப்படி நான் வந்து கஷ்டம் எல்லாம் போய் சேர்க்கலாம், அந்த மாதிரி விஷயம் மட்டும்தான் டிரான்ஸ்போர்ட் லேயர் பண்ணும். நெட்வொர்க் லேயர் தான் வந்து எந்த நெட்வொர்க்கு இந்த பேக்கெட் போகணும், அந்த நெட்வொர்க்ல எந்த ஐபிக்கு போகணும் அப்படிங்கிறத தீர்மானிக்கிறது. அந்த நெட்வொர்க்கை அடைவதற்கு மேக் அட்ரஸ்லாம் தேவைப்படுது. அதெல்லாம் டேட்டா லிங்க்ல பார்த்துக்கோ. அதுதான் நம்ம கொஞ்சம் விளக்கமா நம்ம நாளைக்கு பார்க்க போறோம். வேற ஏதாவது கேள்வி இருக்கா? நல்லது.
No, brother.
So, is there any possibility, like in the transport layer, will there be any interconnection, like any changes in connection while a packet, a segment is being sent to the end user? Like, இப்போ வந்து ஒரு சில பேக்கெட்ஸ் செக்மெண்ட்ஸ் வந்து இந்த டிரான்ஸ்போர்ட் லேயர்ல வந்து சேஞ்ச் ஆகுறதுக்கு வாய்ப்பு இருக்கா சார்? இப்போ மாறி போறதுக்கு வாய்ப்பு இருக்கா? எண்ட் டெஸ்டினேஷன் ரீச் ஆகாம? ஓகே சார். ஓகே. ஓகே சார். ஓகே. ஓகே சார். ಇಲ್ಲ ಸರ್.